Chapter 1.4 Data, its representation, structure and management. 1.4a Number systems and character sets. Counting is one of the first skills that a young child masters, and none of us consider counting from 1 to 100 difficult. However, to count, we have to learn, by heart, the meanings of the symbols 0, 1, 2, 9 and also to understand that two identical symbols mean totally different things according to their place in the number. For instance, in 23 the 2 actually means 2 by 10. But why multiply by 10? Why not multiply by 6? The answer is simply that we were taught to do that because we have 10 fingers, so we can count on our fingers until we get to the last one, which we remember in the next column and then start again. We don't need to count in tens. The ancient Babylonians counted in a system, which is similar to counting in sixties. This is very difficult to learn because of all the symbols needed, but we still use a system based on sixties today. 60 minutes equals 1 hour, 60 seconds equals 1 minute, 6 by 60 degrees equals 1 revolution. Instead of increasing the number of symbols in a system, which makes the system more difficult, it seems reasonable that if we decrease the number of symbols the system will be easier to use. A computer is an electronic machine. Electricity can be either on or off. If electricity is not flowing through a wire, that can stand for 0. If electricity is flowing, then it stands for 1. The difficulty is what to do for the number 2. We can't just pump through twice as much electricity. What we need is a carry system, just like what happens when we run out of fingers. What we need is another wire. The computer can continue like this forever, just adding more wires when it gets bigger numbers. This system, where there are only 2 digits, 0 and 1, is known as the binary system. Each wire, or digit, is known as a binary digit. This name is normally shortened to bit. So, each digit, 0 or 1, is 1 bit. A single bit has very few uses, so they are grouped together. A group of bits is called a byte. Usually, a byte has 8 bits in it. One type of data that needs to be stored in computer systems is the letters of the alphabet. These are stored as codes which look like binary numbers. For instance, it could be stored as 000, beat as 001 and so on. Unfortunately, there are only 8 possible codes using 3 bits, so we could store the letters A to H but not the rest, and what about the lowercase letters and punctuation N? The computer can store as many characters as necessary simply by using more and more bits for the code. Some systems don't need to be able to recognize a lot of characters, so they only use a few bits for each character. The number of bits needed to store one character is called a byte, which is usually said to have 8 bits because most systems use 8 bits to store the code for each character. We now have enough codes, but another problem arises. If my computer stores 8 as 01000001 and your computer stores 8 as 01000010, then the computers cannot communicate because they cannot understand each other's codes. In the 1960 Ascii meeting in America agreed a standard set of codes so that computers could communicate with each other. This standard set of codes is known as the Ascii Set. Most systems use ASCII, so you can be fairly sure that when you type an A it is stored in the computer's memory as 01000001. However, you can't be certain because some systems use other codes. A less common code is called Ascii. It was developed for use by larger-scale computer systems and differs in that the code for each character is different than that used in ASCII. Notes: all the characters that a system can recognize are called its character set. ASCII uses 8 bits, so there are 256 different codes that can be used and hence 256 different characters. This is not quite true. We will see why in Chapter 1.6. A problem arises when the computer retrieves a piece of data from its memory. Imagine that the data is 01000001. Is this the number 65, or is it A? They are both stored in the same way, so how can it tell the difference? The answer is that characters and numbers are stored in different parts of the memory, so it knows which one it is by knowing whereabouts it was stored.